Welcome to qnawire.
So now we'll work on problem 109 from chapter 13. In this problem, we're asked to calculate the molality and Van Hoff factor for two aqueous solutions. In the first case, we have a 0.5% KCl solution, and we're told that the freezing point is negative 0.243 degrees Celsius. Excuse me. So first of all, we have a percent mass concentration. So we can convert that to molality by calculating moles of KCl. So since we have 0.5% KCl, we can assume that we have 0.005 kilograms of KCl per 1 kilogram of water. If you calculate the percentage using those two values, you'll get 5% or 0.5%. So 0.005 kilograms is 5 grams. And we can convert that to moles by dividing by the molar mass of KCl, which is 74.55. And that gives us a value of 0.0671 moles. Since we set our value of water at 1 kilogram, that means our value for molality is the same as what we have for the moles. So what we need to find out is the molality, which we just calculated, and then we need to find out the Van Hoff factor. So we know dt. dt is given in the problem as negative 0.234. And so we just calculated molality. So we can plug this into our equation. And we know the freezing point constant for water is 1.86 degrees Celsius per molality. So from this, we can calculate our value for I by simply dividing both sides by this term here. And when we do that, we get a value of I as 1.87. So it's close to 2 as we would expect, but it's not completely 2 because it's not ideal behavior. So for part B, we have our second situation, which is 1% mass of sulfuric acid, H2SO4. So that's and we also have a value of negative 0.423 as our freezing point. So again, we can assume a certain mass. So we have 0.01 kilograms per 1 kilogram of water. So we have twice the mass we did in the previous example because we have twice the mass percent. So again, we convert from this moles, this grams to kilograms. So 0.01 kilograms is 10 grams. And then we can convert that to moles by dividing by the molar mass, which is 98.079. That gives a value of 0.102 moles. which, because we have set our concentration as per 1 kilogram of water, we can directly convert to molality. So that's the first answer. Then we're given dt in this problem as negative 0.423. This is equal to negative I, the molality, times the freezing point constant, which is 1.86. And so we calculate our I value by dividing both sides by the molality and constant to be 2.23. It's above 2 because H2SO4 is a diprotic acid, so both of these hydrogens have a chance to go into solution.